Hey guys, it's Mr. Holly. I have been tasked with talking to you about interpreting box and whisker plots. So we will be reading and interpreting these box and whisker plots and talking more about them. At this point, you should know how to create one. Now we will look more deeply into what they mean. So anytime we see a box and whisker plot, we need to just kind of generally talk about the structure here. I cannot tell from this graph, this box and whisker plot, how many pieces of data there are. I don't know if there were 100 tests in this case, 20 tests, 30 tests. I have no idea how many tests we're taking. I don't know the average of the tests. I don't know some of the information about it, but this communicates to me how the tests are distributed into quartiles, into 4 groups. I have my highest 25% right here. I have my second 25% right here. And then at the bottom here, I've got my lowest 25%. And what this means is, even though this section is much larger, it covers a bigger range of numbers, 25% of the test scores fell within this section between 38 points and 72 points. So even though this is 6 and this is, what, 34, the distance between these two numbers, each of these ranges have the same amount of test scores. So this would mean maybe like 10 students scored in this range, 10 students scored in 88 to 96 range, 10 students scored in 72 to 88 range, and 10 students scored in 38 to 72 range. I don't know that it's 10, I'm just saying in general, what this means is it's the same number for each of these 4 quartiles. Okay? So as we read this data, we're using that structure to try to make sense of and answer some of these questions. So, if I look all the way at the edge here, I can find the upper extreme, which is 102. This is the highest test score. Number one, what was the highest test score? It's 102. Secondly, what percent of the class scored above a 72? So let's find 72. The bottom of this kind of functions like a number line. And let's find 72. And 1, 2, 3 quartiles, or 3/4 of the students scored above a 72, so that's 75%. Number 3, what is the median score? Well, the median is the center piece of data. Doesn't mean it's the average. It means if you took if there were, 11 people, you take the top 5 away, you take the bottom 5 away, and what's the one in the middle? It's the number right in the middle of your data. In this case, it is right here. It is above it's when you got 25%, 50% to the left, and then you got 25%, 50% to the right. The median is the center of your data. That would be 88. Would be the median test score. What percent of the class scored between 88 and 96? Well, that is one of these boxes, one of these quartiles, 1/4, so that's 25%. Do you think the test was too hard for the students? Okay, so if I look at this test, I can see that 25% scored 96 and up, 50%, 2/4, scored 88 or better, that's 50% making a B, and 75% scored 72 or up. So I would say, no, 75% passed 70 or better, and 50% scored 88 or better, which is like a B. So if you've got half your kids making A's and B's, that seems like the test is pretty fair. Okay? Let's look at another example. Average minutes per night spent on homework. Okay? So I've got 4 sections here, each one consisting of 25% of the students. it's a little bit skewed. It looks like there are some students that spend a really like exorbitant amount of time, a ton of time on homework, and then you've got some students that spend very little, and then here you've got your 50% in the middle that spend kind of that reasonable amount of time here. All right, what percent of sophomores spend more than 60 minutes? So start at 60, go up. This is one of those quarters. This is one quartile. It's 25%. What is the range of the times that the middle 50% of the sophomores spend on homework per night? So the middle 50% is going to be the box. You've got 25% above it, 25% below it, and then 50% for that box. And the range is 20 to 60. So 20 to 60 minutes. All right? 9. How many sophomores do not do homework? How many sophomores do not do homework? And the truth is, we do not know. Cannot be determined. I don't know how many don't do homework. I know that there is someone that's not doing homework, at least one, but I don't know how many do homework, how many zeros there are here. What percent of sophomores spend less than 20 minutes per night on homework? And that's 25% of the sophomores. Okay. All right. Let's look at questions 12 and 13. These are about TV and homework. Number 12, what percent of the sophomores watch TV for at least 15 minutes a night? So let's look at the TV graph here. 15 minutes a night, so I'm finding 15. And how many of these quartiles are greater than 15? So I see 1, 2, 3 quartiles to the right of 15. That means 75%. Each quartile is worth 25%, remember. What is the third quartile, which is also, that's the median, for the TV time data? What is the median for the TV time data? And that is 60. 60. All right. And number 14, is it more common for a sophomore at the high school to spend more than 1 hour on homework or more than 1 hour watching TV? So how many spend more than 1 hour on homework? 25%. How many spend more than 1 hour on TV? 25, 50%. Right? Both of these, 50%. So, 50% spend more than 60 minutes on homework, while 25%, I'm just going to ditto that, spend more than 60 minutes on, excuse me, I said that wrong, forgive. 50% spend more than 60 minutes on TV time, while 25% spend more than 60 minutes on homework. Sorry about that. Got my numbers crossed up, got it. Everybody clear though? 50% watch TV for an hour or more. 25% do homework for more than an hour. Okay? All right. Identify if each of the statements is true, false, or cannot be determined. Okay. Some sophomores did not watch TV. Okay, so if that was true, we would have 0 as one of our values. Our lowest value would be 0. So watching TV, lowest value 0, true. The TV box and Whisker graph contains more data than the homework graph. I don't know. I don't know how much data there is for any of that, so it cannot be determined. 25% of sophomores spend between 48 and 60 minutes per night on homework. So, is there a quartile that goes from 48 to 60? There is. One quartile, that's true. 15% of sophomores didn't watch TV that month. This cannot be determined. We don't know how many students said 0. Could it have been 15% of students? It could. All I know is 25% are 15 or lower. Could be 15% said 0 and the other 10% said something of 15 minutes or less, but all I know is that 25% fall in that range. In general, these sophomores spend more time watching TV than doing homework. Said that is true. 60% spend over an hour, or excuse me, 50% spend over an hour, while up here 50% or 25% spend over an hour. We look at like the general median here, we've got more students watching more TV. So that's true. The TV data the TV data is more varied than the homework data. TV is more varied than the homework data. It has a larger range. So I'm looking at the range. It has a range of 225, while the range on homework is just 190. So I would say that that is true. The ratio of sophomores who spent more than 110 minutes per night watching TV to those who spent less is about 2 to 1. Well, let's look. More than 110 is 25%. Less than 110 is 75%. And that would not be 2 to 1. That would actually be 1 to 3. False. 225 sophomores watch TV. We don't know. Again, box and whisker plots do not tell us the number of data. They don't tell us how many data points we have. They don't tell us, you don't see the frequency like you would in a dot plot or like a stem and leaf chart or something like that. I don't know how many, this could be just a few kids, this could be a ton of kids. I don't know how many students are surveyed here. I just know the percentages that fall within these quartiles. Like 25% of students fall between these two values. 25% fall between these two values. How much is 25%? It depends on how many students they asked, and I do not know. There's no way for us to know just from the box and whisker plot. Twice as many sophomores watch TV for more than 1 hour than do homework for more than 1 hour. Okay, so watch TV for more than 1 hour, that's 50%. Do homework for more than 1 hour, that's 25%. Is that twice as many? Yes, that's true. All right. On to the next page here. We are comparing the temperatures of Milwaukee and Honolulu. And we have a little table here for us to check out. Milwaukee. So we're using this. What is the median? That would be this middle center of data here. That's 57. The minimum is 26. The maximum is 80. The lower quartile is 35. The upper quartile is 73. And the interquartile range is the distance between the quartiles. What is the range between the lower quartile and the upper quartile? And that would be 73 minus 35, 38. All right, now let's check out Honolulu. Watch how much different it is in Honolulu. The median, 84.5. The minimum, 80. The maximum, 88. The lower quartile, 81. The upper quartile, 87. Lower quartile, upper quartile. The range, 81 to 87, that's just 6 degrees for the interquartile range. So a good question to ask here that you might need to answer is, how would you compare these two box and whisker plots? And what we would say is that this has less, it varies less. We would say that Honolulu varies less than Milwaukee. And what we would look at is the interquartile range to see the amount of variation that's happening within these cities. So you want to look at the interquartile range to see the variation. This, 50% of the days fall within a 38-degree window. In Honolulu, 50% of the days fall within